Hello students, let us discuss limitations of octet rule. In the previous video, we discussed about the method to find out the Lewis structure for the different compounds. As we know that the atom should get complete octet, then it is stable. So on the basis of that only we find out the Lewis structure for different compounds by using this method. But there are some compounds like lithium chloride, beryllium hydride, boron fluoride. When you check the Lewis structure for these compounds, you can find that in the central atom, the number of electrons surrounding to it is less than 8. Let us find out for the case of lithium chloride. Here, the chloride is stable because all electrons, total 8 electrons are there surrounding to chlorine. But here the lithium is getting only 2 electrons. So we know that it is only getting 2 electrons. So the octet is not complete here. In the case of beryllium hydride, as we know that the hydrogen is stable with 2 electrons. So hydrogen is getting 2 electrons. But what about the beryllium? When you check the number of electrons surrounding to beryllium, that is equal to 4. That is less than 8. In the case of this example, you can find out the central atom, that is boron, is getting only 6 electrons. So when you compare these three structures, here the central atom is getting 2 electrons, here 4, here 6. That means the number of electrons surrounding to the central atom is less than 8. Such type of compounds, we can say that there is a limitation of octet rule, and we can say that there is an incomplete octet of the central atom. That means less than 8. So we can say that in some compounds the number of electrons surrounding the central atom is less than 8. This is especially for the case of the elements having less than 4 valence electrons. When you look at the structure here, lithium chloride, beryllium hydride, boron fluoride. In this case, the central atom is lithium, barium and boron respectively. They have 1, 2 and 3 valence electrons only. So such type of examples usually form a incomplete octet of the central atom. But there are some compounds in which the central atom is getting more than 8. When you compare these structure, in the case of PCl5, here the central atom, that is phosphorus, is getting total 10 electrons. In the case of SF6, the central atom sulfur is getting total 12 electron, and in the case of sulfate ion, sulfur atom is getting 12 electron. How 12 electron? When you count the number of electrons, that is total 2 here, 2, that is 4, 5, 6. 6 bond, so 6 into 2, that is 12. So in these cases, we can find out the central atom is surrounded by electron that is more than 8. So that means that type of examples are called as the example in which the central atom is getting more than 8 electrons. In the first case, that is 10 electron around the phosphorus, 12 electrons around the sulfur, and here also 12 electrons around the sulfur. So we can say that that is having expanded octet. So the elements in and beyond the third period of the periodic table have, apart from 3s and 3p orbitals, they also have 3d orbitals. We know that in the third shell, instead of 3s and 3p, 3d orbitals are also available for bonding. So in a number of compounds, these electrons are more than 8 valence electrons around the central atom. Because of this reason only, they have expanded octet. Let us take some other examples. like nitrogen oxide, nitrogen dioxide. When you count the number of electron, that is the total number of valence electron, that is 6 in the case of this example, oxygen 6 valence electron, nitrogen 5 valence electron. So when you make the sum, you will be getting 11. That is an odd number. So when there is an odd number of total valence electron, always there will be one electron which will be odd here. When you compare in the case of nitrogen dioxide, there is one odd electron. Because when you make the sum of the valence electron of 2 oxygen atom and 1 nitrogen atom, you will be getting an odd number. So in that case, always will be getting an odd electron in the compound. So we can say that it will not get 8 in such case when there is an odd electron. So this is also a limitation of octet rule. So the odd electron molecules, in this molecule an odd number of electron like nitric oxide and nitrogen dioxide, the octet is not satisfied for all the atoms here because of the odd electron. What about the case of xenon? Xenon is a noble gas element. That means we have learned that the noble gases have completely filled octet. That means they have 8 valence electron because they belongs to 18 group. So their valence electron is 8. So as according to the octet rule, the element is combining to other atom. The atom is combining to other atom in order to complete the octet. Since the noble gases have most stable configuration, that is because of the completely filled orbital. So we expect that it will not going to be reactive with other atoms because of a stable configuration. But still these can form the compound like XeF4. When you look at the structure here now, out of 8 electron, 1 electron is shared with the fluorine. This fluorine, 1 electron is shared with this fluorine. 1 here, 1 here. So when you find out the total number of electrons surrounding to xenon, that is definitely more than 8. So we can say that even though the noble gas species have a stable configuration, but still they can form the compound with the highly electronegative elements like fluorine and with oxygen. So this example, that is XeF4, is showing a limitation of an octet rule. Similarly, XeF2, XeO4. So it is clear from that octet rule is based on the chemical inertness of noble gases. However, some noble gases, for example xenon and krypton, also combine with oxygen and fluorine to form number of compounds which is shown here. So these examples, that means these compounds are showing the limitation of octet rule, because as according to the octet rule, why the atom is combining, that is due to attain a stable configuration. But these elements like the noble gases have completely filled orbital, they have a stable configuration, but still they are combining with the other element. So this is actually the limitation of octet rule. The octet rule does not explain the shape of the molecule. When we make the Lewis structure, according to the octet rule for water, it will be in this way. But if you want, you can make this one in a straight line form like OH. You can, if you want, you can make in this way. But why we are making the water in this shape? Because the shape of the water is bend shape. So this explanation, that is the octet rule, does not explain the shape of the molecule, like why water is bend shape. So that is one of the limitation of octet rule. Even it does not explain the relative stability of the molecule, being totally silent about the energy of a molecule. this concept, that is a octet rule, does not explain the stability of a molecule. So because of such limitation, so the method which we have followed to find out the Lewis structure may not be applicable for all the compounds. So let me explain the simple way of making the formula, that is a Lewis structure, that is applicable for some molecules. Like the case of ammonia, first of all, write down the central atom and the terminal atoms in this way. Write the central atom, that is a nitrogen is a central atom, and write 3 hydrogens surrounding to nitrogen. Once you are writing in this way, now keep the dots. Dot means the valence electron. You know that nitrogen belongs to 15 group, so 5 is the valence electron and hydrogen have 1 valence electron. Now put the valence electron in each atom. So it will be in this way. Now 5 electrons are there surrounding to nitrogen. But here 3 hydrogens are there. So you can share that, you can form a bond with the 3 hydrogen with 3 electron of nitrogen. So you will be getting the structure like this. So this is the Lewis structure for ammonia. So from this it is clear that there is 3 bond pairs and there is only 1 lone pair, that is this one. 3 bond pair and 1 lone pair. So how easily we have made this structure? Let us try for BrFi. Here the central atom is Br and there are 5 terminal fluorine. So write down the central atom and terminal atom in this way with the valence electron. Since Br and F belong to 17 group, so all of them have 7 valence electron. Out of 7 electron, 1 electron is shared with 1 fluorine, other with the other fluorine, like this. It share out of 7, the 5 electron it is shared with the 5 fluorine. So there will be a 1 lone pair. That means out of 5, that means out of 7, 5 are taking part in the bonding, but 2 electron is remain. So that will be a lone pair. So keep the bond like this. So we'll be getting 5 bond pair and 1 lone pair is there. So this is the structure for BrFi. So how easily we have made the structure for some of the examples which we have discussed here. So you also try some examples like SF6 in the same way, IF7, XZF2, XZF4. So similarly, when you try these all molecules, you will be getting the Lewis structure for it. Even though the octet rule is applicable for most of the examples, but is showing a limitation for some examples, like the compound having incomplete octet, the compound having expanded octet, the molecules which have odd electrons, and the compounds of noble gases. And it does not explain the shape of the molecule, that is also one of the limitation, and it does not explain the relative stability of the molecule. So these are the limitations of octet rule. So in this video, we discussed about the limitation of octet rule and the simple method to find out the Lewis structure for some of the molecule. So this is all about the limitation of octet rule. So have a nice day.